We step into an elevator, push a button, and just expect it to work. We do it every single day without a second thought. But behind that simple press of a button, there's a hidden technological revolution, a story of how we went from a tangled mess of wires to a super smart, streamlined system. So today, let's pull back the curtain on the incredible evolution of elevator tech. So what's really happening behind those smooth metal walls? I can tell you, it's way more than just ropes and pulleys these days. We're talking about the elevator's nervous system, a complex communication network that's become amazingly sophisticated. To really appreciate just how far we've come, we've got to look at where we started. And originally, getting an elevator to work was a huge challenge, all because of something called traditional or parallel wiring. Okay, get this. In the old days, for every single function, every floor button, every little indicator light, every command, you needed a separate, dedicated wire running all the way from the control panel to the moving cabin. In a 5-story building, that's already a headache. But in a skyscraper, forget about it. It was a logistical nightmare, a massive, tangled web of copper that was crazy expensive to install, super heavy, and, oh man, a total pain to troubleshoot when something went wrong. And really, the difference between the old and the new is just night and day. We went from a massive bundle of wires to just a few. From extreme mind-bending complexity to a streamlined, simple design. And this is the real game changer. Troubleshooting went from a process that could take days of hunting for one bad wire to a system where you can diagnose a problem fast and efficiently. This wasn't just a small step up. It was a total transformation, all thanks to something called serial communication. So, how did this massive leap forward happen? Well, it's all about language. Modern elevators basically learned to speak a new, efficient digital language. This allowed all the parts to talk to each other over just a couple of wires. Let's get to know the key protocols that gave elevators their voice. First up, we've got one of the most common and trusted protocols in the whole industry, CAN bus. The absolute best way to think of it is as a multi-lane superhighway for data. Instead of every car needing its own separate dirt road to get to the destination, CAN bus provides one big highway where tons of different signals can travel at super high speeds, all at the same time. And the power of CAN bus is really threefold. It allows for incredibly high-speed data exchange between the main controller, the car, and all the floor panels. It's also fantastic at ignoring electrical noise and interference, which for you and me means fewer glitches and a way more reliable ride. And because multiple devices can all talk at once, the whole system just feels incredibly responsive and intelligent. Now, the other major player on the scene is RS-485. If CAN bus is the local superhighway inside the system, you can think of RS-485 as the long-haul trucking expert. Its mean strength is transmitting data reliably over really, really long distances. This makes it absolutely perfect for connecting the main controller, which might be in the basement or on the roof, to the call buttons on every single floor of a super tall building. It makes sure every single call is heard, loud and clear, no matter how far away it is. Okay, but all of this smart digital communication needs a physical pathway, right? Especially to a cabin that's constantly moving up and down. And that brings us to the true unsung hero of the modern elevator, the traveling cable. Honestly, the best analogy for the traveling cable is to think of it as the elevator's lifeline, its umbilical cord. It's this highly engineered, super flexible bundle of wires that hangs in the shaft, connecting the stationary control room to the moving cabin. It has to bend and flex constantly, 24/7, without ever failing, delivering both the power for the lights and all the data that makes the elevator smart. It's a component that absolutely cannot fail. And, not all of these lifelines are created equal. They're specialized for the job. Flat cables are what you'll see most often because they're incredibly flexible. For those really tall skyscrapers or high-speed elevators, you'll see stronger, more durable round cables. And then you get the modern marvels, hybrid cables that can bundle power, data, and even fiber optics all into a single high-performance package for the smartest buildings out there. Now, having all this amazing technology is one thing, but making sure it works safely and reliably for years and years, well, that all comes down to one thing: professional, absolutely precise installation. This formula might look a little complicated, but it boils down to one simple, critical idea: precision is everything. Figuring out the exact length of the traveling cable isn't guesswork. Technicians use a specific formula to account for the height of the shaft, the necessary loop for movement, and the connections at both ends. Being off by even a little bit can cause the cable to snag, stretch, or wear out way too fast, putting the whole system at risk. And getting that length right is just rule number one. The cable has to be installed perfectly straight, with zero twisting, which can fatigue the wires inside until they just break. You need proper strain relief clamps so the cable's own heavy weight doesn't damage the delicate connections. It needs enough space to hang and move freely without rubbing against anything. And it has to be protected from any sharp edges. Every single one of these steps is vital for ensuring decades of safe, reliable operation. So, when you put it all together, the smart serial communication, the robust protocols, and the perfectly installed traveling cable, what's the end result? It's a complete and total upgrade in every single way. This quote from our source material just nails it. This technology makes elevators faster to install and way easier to maintain, which is great news for building owners. But the most important part is this. By dramatically increasing the system's reliability, it makes them more efficient and fundamentally so much safer for every single person who steps inside. So the next time you're in an elevator and you feel that smooth, quiet, and perfectly responsive ride, now you'll know why. It's not magic. It's the result of this incredible, hidden technology working in perfect harmony behind the walls. That elegant dance of digital signals and durable, flexible cables. It really gets you thinking, doesn't it? This kind of technological leap is happening all around us, hidden inside the everyday objects we totally take for granted. So what hidden technology will you discover next? For anyone who actually designs or installs these systems, or if you're just fascinated by this kind of tech, the journey doesn't have to stop here. The experts at Novenpuya Lift specialize in these advanced systems. You can check out their work at novenpuyalift.com, or you can even reach out to them directly on WhatsApp for a consultation. And that's all for this explainer.